How can n into p is equal to ni square remain constant while we add more donor atoms and increase n? P, that is the concentration of holes, falls below the intrinsic level as more n-type donor dopants are added to the crystal. This occurs because many of the new electrons donated by the donor atom recombine with the already existing holes which were created due to the thermal excitation or due to the room temperature. So n into p is equal to ni square is constant for a given crystal before doping and after doping. Before doping, depending on the environment temperature, some of the covalent bonds break. If it is absolute zero temperature, the temperature is 0 Kelvin, then no covalent bonds break. It acts as a perfect insulator. But as temperature rises, because of that thermal energy, some covalent bond breaks, electron hole pairs are generated. So we have equal number of holes and electrons in this situation. Now at this temperature, at this non-zero Kelvin temperature, when you do the doping, you are adding donor atoms. Each donor atom donates one electron. Say you are adding n donor atoms, n group 5 elements, then you will get same number of free electrons. If you add x dopants or x donor atoms, then you will be getting x free electrons. But out of these x free electrons, some part of the free electrons will be recombining with the already existing holes. So we can say that the number of holes decrease after doping. Why? Because doping introduces only electrons. Prior to doping, already same number of electrons and holes are present. After doping, we are introducing only electrons because each donor atom gives one free electron. Some of these electrons recombine with the existing holes, so holes decrease. The product n into p will still remain constant and is equal to ni square. N into p is equal to ni square is valid before and after doping, and this is called as mass action law. So even as p decreases, number of holes decreases, but n is increasing. So whatever n is increasing because of doping, that is counteracted in the opposite direction by the decrease in the holes. N into p product doesn't change with doping. N into p product changes only with temperature because Ni is a function of temperature. So N into p changes only with temperature and does not change with doping. So Ni equation is given by this relation. So Ni is proportional to T power 3 by 2 or Ni square is proportional to T cube. This relation gives the dependence of energy band gap and temperature. How the intrinsic concentration Ni depends on the temperature and energy band gap.